Hi GOH, this is Unit 7, Lesson 2, and today we're going to talk about dilations in the coordinate plane. So this first box that I have here is really just a review of some things that we learned yesterday. When you're dilating a line segment AB, not containing the center by a scale factor of k, then it produces the image A prime B prime. So always remember that the image is the one with the primes. So basically I'm starting with AB right here, I'm multiplying it by some scale factor, and I'm getting the image A prime B prime. We learned yesterday that that image will be parallel, so that's one important thing to keep in mind. And how do I get the image? Basically, I take the original line, AB, the original points, A and B separately, and I multiply each of them by that scale factor, and I get my new points. Okay, but the big thing to remember is you're getting another line that's parallel to it, and the point that I'm dilating it from is point C. So let's do some with some points here. The coordinate plane gives us an excellent way to perform dilations and to verify these properties. The points A is 0, 2, B is negative 4, 0, and C is 3, 4 are plotted. Find and plot their image points after a dilation by a scale factor of 2 centered at the origin. So this is super simple to do. All you're multiplying is x and y by 2, and you'll get the image. So if I multiply 0 times 2 is 0. 2 times 2 is 4. My new point is 0, 4, and I'm going to put that right on my graph and call that A prime. B is the point negative 4, 0. Again, I'm going to multiply the x and the y by 2. So negative 4 times 2 is negative 8, and 0 times 2 is 0. And then you're going to plot that. So I got negative 8, 0, and that's B prime. And then C is the point 3, 4. So to find its image, I multiply the x and the y by that scale factor, and I'm going to get 6, 8. And I'll plot 6, 8. And C is going to be right there. Okay. How can I verify that C prime is twice the distance from the origin as C? With A and B, they're both on a vertical or horizontal line. They're on the x and the y axis, so you could actually just count. Like A is 2 away and A prime is 4 away, so it's twice as far. B is 4 away and B prime is 8 away, so it's twice as far. To do C, we could just use our distance formula. Okay, they're not asking us to do it, they're just asking us how would I do it. To verify that C prime is twice the distance from the origin. I'm talking about the length right here. And just like we were talking about yesterday, if I was to take a ruler and draw a line, okay, you can see that when I do a dilation, so I'm dilating from the origin, which is the 0, 0, point C is moving further away because it was a dilation of 2. If it was a dilation of a fraction like 1/2, then C prime, the image, would be moving closer. All right, so dilations from the origin are the most important in the coordinate plane. Their algebraic rule is extremely easy. So whenever we're doing a dilation, if I have a point xy and I'm dilating from the origin with a scale factor of k, all I'm doing is multiplying the x and the y by that scale factor. And that's exactly what I did up above. So this is just telling us the rule. All right, let's do one that's a tiny bit more complicated. So which of the following is the image of negative 410 after a reflection in the line y equals x and then a dilation centered at this origin with a scale factor of 3/2? So we have to remember our rules for a reflection over the line y equals x. And I just flip-flop those points, so that would give me 10, negative 4. And then I want to do a dilation with a scale factor of 3/2. So I'm going to multiply 10 times 3/2, and I'm going to multiply negative 4 times 3/2. And you can do that in your calculator if you want. 10 times 3/2 is 30 over 2, which is 15. And negative 4 times 3/2 is negative 12 over 2, which is negative 6. All right, so nice and easy. All right, number 3 on the back. Segment AB is shown below, has the endpoints of negative 1, 4, and B has the endpoints of 4, 2. Plot the image of AB after a dilation by a scale factor of 3 with the center at the origin. All right, so all I'm doing this time is I'm multiplying negative 1 times 3. which will give me negative 3, and 4 times 3. So that's the image, negative 3, 12. And that would be right there. Call that A prime. And B prime, again, I'm multiplying by 3. 4 times 3 is 12, and 2 times 3 is 6. So B prime is 12, 6. And that would be right there. Okay, I'm going to connect these. So using a ruler, I'll connect those points. Find the slope of AB and the slope of A prime, B prime. So the slope of AB, so I'm using these points right here, A and B. Remember, my slope is the change in y over the change in x. So I'm going to have 2 minus 4, and 4 minus negative 1 is negative 2 over 5. And then I'll find the slope of A prime, B prime. So I'll do that in a different color, just to make sure. I forgot to do this one, yellow. All right, make sure I'm taking those right points. So the slope is going to be 6 minus 12, and 12 minus negative 3, negative 6 over 15, which is also 2/5. Now we talked about this yesterday, how if you dilate a line, you're going to get another line that's parallel, and that's exactly what happened because they have the same slope. So what do these slopes tell you about the segments? They are parallel. And in the next part, they want us to find the length of AB and A prime, B prime in simplest radical form. All right, so again, I'm going to do AB, which are I have them highlighted in yellow. So 4 minus negative 1, and I'm squaring it, and 2 minus 4 squared. So that's going to give me 5 squared, which is 25, and negative 2 squared, which is 4. So that gives me radical 29. And A prime, B prime. So I have 12 minus negative 3, and 6 minus 12. So that gives me 15 squared, which is 225. And I have negative 6 squared, which is 36. And if I add those together, let's see what I get. Radical 261. Okay, and if you take the square root of, if you found the square root of each of these, you would see that yes, the length is going to be 3 times as big. Okay, all right, so those are just some things that we learned. Let's do this next one, and this is an important one. This is one that's always on the regents. So please remember, when you dilate a line, and we just did this in the examples up above, but if I dilate a line from a point that's not on the line, I'm going to get another line that's parallel. That's one scenario. The second scenario is if I dilate a line from a point that's on the line, then I get the exact same line. All right, so let's look at an actual equation of a line. I have 3y plus 5x equals 12, and I'm dilating it with the center at the origin by a scale factor of 1/2. So let's take this 3y plus 5x equals 12. Let's get y by itself. So I'm going to move that 5x over to the other side. Divide by 3. So I have y equals negative 5/3 x plus 4. So if I was to take that line and dilate it, I'm going to get another line which is parallel. Remember, parallel lines have the same slope. So my new line will also have a slope of negative 5/3. Now I'm going to have to take my y-intercept, which is 4, and I'm going to multiply it by the scale factor. So that's what's changing when I dilate a line. So 4 times 5 is 20. Oh, I'm sorry, I'm dilating it by a scale factor of 1/2, sorry. So I'm going to take that 4, and I'm going to multiply it by 1/2, which is 2. So that's my new y-intercept. So my new point is just going to be y equals negative 5/3 x plus 2. So that's one case. So if I dilate a line from a point not on the line, in this case the origin, you get another line that's parallel. So parallel lines have the same slope. Leave the slope alone. Take your y-intercept and multiply it by the scale factor. Now this next example, I have the line y equals 3x. the y equals 3x has a y-intercept of 0, and it has a slope of 3, so it's right here. It looks just like this. Okay, if I was to dilate that from the origin, well, the origin is the center of dilation. It's on the line. Therefore, the answer is just the exact same line. So those are two different scenarios, and we will talk about those tomorrow and practice those.